The CLO for this lesson is that students will be able to graph, in writing, quadratics using factored form and the key features, as well as the following language, if-then statements, factored form, quadratic, parabola, x-intercepts, y-intercept, and vertex. So, in your own words, explain what you're going to learn how to do in this lesson. So starting with the vocabulary, factored form is a quadratic form that looks like, and usually it's two parentheses being multiplied together like this. However, there can also be some number, like some a in front of those parentheses, and it'd still be factored form. All right, so x-intercept. Go ahead and select everything that's true about x-intercepts. So x-intercepts are where the graph crosses the x-axis. Therefore, y is going to be 0. All right, go ahead and click everything that's true about y-intercepts. For y-intercepts, it's where the graph will cross the y-axis. Therefore, it's when x equals 0. And then go ahead and click everything that's true about the vertex. The vertex is the top or bottom of the hump. It's also known as the parabola. And depending on which way the vertex is facing, it's the minimum or maximum of the graph. So, in factored form, let's talk about the quick ways to graph from factored form by how to quickly get all of the key features. So for the x-intercepts, if you take something in factored form like this, what's going to become 0 for the x-intercepts? For the x-intercepts, the y becomes 0. And how would I solve this for x? We would use the zero product property. Remember, the zero product property just says to make each parentheses equal 0. So the first answer is parentheses number 1 equaling 0. And you solve for that, and then it's going to be comma 0. And then you're going to take parentheses number 2 and make that equal 0 and solve for x. Whatever your answer is, it's going to be comma 0. So for y-intercepts, which part of this graph is going to become 0? For y-intercepts, it's the x that becomes 0. And it's both this x and this x that will become 0 for the y-intercept. So for the y-intercept, we're going to plug in 0 for x and put it in a calculator. For the y-intercept, the x value is going to be 0, and the y value will be the answer from the calculator. And then for the vertex, get the x value of the vertex. It's in the middle of the two x-intercepts. Sometimes it's really easy to count to the middle, and sometimes it's not. So when it's not, you can always find the middle by adding the two numbers, then dividing by 2. And I'll show you how to do that when we get to the example. For the y value, you end up plugging in x value you found, then put it into a calculator. find the y. So this is how we do it all. So let's do it on a couple examples. So for this one, to get the x-intercepts, we're going to use the zero product property. Remember, the zero product property just has to take each parentheses, like x minus 2 is one of the parentheses, and you make it equal 0. And you're going to do the other parentheses, the x plus 6, to make that equal 0. And then we have to solve both of those for x to get our two answers. So how am I going to solve this one for x? Add 2 to both sides. Because this negative 2 plus 2 is going to cancel. So then we'll have the x, and it's going to equal 0 plus 2, which is 2. Then for this one, how do I solve for x? I'm going to minus the 6. Because plus 6 minus 6 is 0, they eliminate. So then on this side, I only have the x. And on this side, 0 minus 6 is negative 6. So my two x-intercepts, I have one at 2, 0, and one at negative 6, 0. Those are my two x-intercepts. For my y-intercept, I take the equation, and I plug in 0 for both of those x's. And I can put that straight into a calculator if I want. 0 minus 2 times 0 plus 6 is going to be negative 12. So my y-intercept, so when I plug in 0 to the x's, I get out negative 12. So to get my vertex, I need to find my x by the middle of my two x-intercepts. So if I take my two x-intercepts, my two x-intercepts are at 2 and negative 6. If I go from 2 to negative 6, I have 2, then I have to go down to 1, then 0, then negative 1, negative 2, negative 3, negative 4, negative 5. Now I'm at negative 6. These are all the numbers between 2 and negative 6. If I start crossing them out on each end to find the one that's in the middle. So I'm going to take one off of each side at a time. I would find out that this negative 2 is in the middle. Well, sometimes it's not always that easy. So the second way I told you can do it is by adding the two numbers. So I can do 2 plus negative 6. I do that in a calculator, 2 plus negative 6. I get out negative 4. So that's going to equal negative 4. Then you always divide it in half. You're going to divide it by 2. So I have to do negative 4 divided by the 2 to figure out that negative 2 is in the middle of those two numbers, which I also figured out by doing it the cross-out way. But this way helps you even when it's decimals and even when it's weird stuff. You add them together, then you divide them by 2 to figure out the middle. So this is the x for the vertex. X is going to be negative 2. Get the y value. You have to just plug in that x value you found. So if I take the equation and I plug in negative 2 for x, since I just found that negative 2 here, and I put that into the calculator, I'd find out that my y value is going to be negative 16. So the y value of my vertex is negative 16. This one was how we found the x. This is how we found the y. And this is the whole vertex. So these are the 4 key features we found, and we need to make a graph. So I have 2, 0, and negative 6, 0. Those are those 2 points right here. What if I zoom in? Now this scales by 1. So here's 2, 0, negative 6, 0. 0, negative 12. Now I can't see that point because it's too far down. This is only negative 4, so I'd have to zoom out a little bit. And now it's down here. And then my last point is negative 2, negative 16. So I can't see this because this is only going down to negative 12. So if I zoom out, now I can see it. But do you see, to make it fit, they had to go by 5s. Now for tick marks, here's negative 5. So negative 6 just is a little bit after that. And you just have to estimate. Then at this vertex, you would curve up here, curve up there, so that when the equation's graphed, it's x minus 2, x plus 6. It looks like that when it connects its dots. You could have chosen to do a different scale, like this scale where they go by 2s. The problem is that like this one, you see how it gets cut off for this bottom vertex. So you would just need a long graph at the bottom to make that work if you wanted to go by 2s. And if not, you can go by 5s, but then you'd have to estimate where some of those points go. And then make your picture. Okay, so this is another one. It's just slightly different because there is a number in front of the parentheses. But let's do all the key features. So for x-intercepts, how do I solve for my x-intercepts? I have to make each parentheses equal 0. Now you might be wondering, what about this negative 1/2 in front, miss? Why isn't this a part of the x-intercepts? Well, it doesn't matter because it's being multiplied. So if this parentheses equals 0 altogether, 0 times this parentheses times this is still going to be 0. Same thing here. If we make this one equal 0, it doesn't matter about the 1/2 being in front. The 1/2 will matter for other parts, but not for the x-intercept part. So to solve for x, what's my first step in solving for x for this one? I have to minus the 5 away to both sides. Because plus 5 minus 5 will become 0, and I'm just left with x then equaling 0 minus 5 is negative 5. And here, x plus 1, how do I solve this for x? I have to minus 1 to both sides because plus 1 minus 1 cancels. So then x is 0 minus 1, which is negative 1. So my two x-intercepts are going to be negative 5, 0, and negative 1, 0. And then just to prove to you that this 1/2 doesn't matter, my equation right now is of x plus 5 and x plus 1. And if I put minus 5 in here, the answer is going to be 0 because this part's 0. Negative 5 plus 5 is 0. Times whatever this parenthesis is still 0. Times, it doesn't matter if something's in front. Like if 1/2 is in front, being multiplied to 0 is still 0. Even if it's a negative 1/2, it's just getting multiplied to a 0, which is still going to be 0. So anything in front isn't going to change what goes in the parentheses to make the parentheses be 0. So those are my two x-intercepts. For my y-intercept, what do I do with the equation? plug in 0. So I put 0 into both of those x's. If I come here and instead of -5, I put 0 into both of those x spots, I get out -2.5. So therefore, my y-intercept is that when I plugged in 0, I got out -2.5. And finally, for my vertex, to get my x value, it's the middle of my two x-intercepts. So I could write out everything between -5 and -1 and then find the middle. Or I can do the whole process where I take the two numbers and I add them together. So -5 plus -1. And I get -6. Then to find the middle, I divide them by 2. And -6 divided by 2 is -3. So for my vertex, that's my x value. It's going to be -3. Then to find my y value, I take the equation and I plug in that -3 to both the x's. So if I do that in the calculator, -1/2, and then put -3 plus the 5, and then -3 plus the 1. Because these were x's and I'm plugging -3 into both of my x's in my equation here. And I get out the answer of 2. So it's going to all equal 2. So that's the y of my vertex. And use them to make a graph. If I plug them into Desmos to make my graph, I have -5, 0, so -5 with 0. I have -1 with 0 right here. So if I zoom into the 1 scale, you can see them both now on their numbers. Next is 0 and -2.5, which is right here. And then finally -3 with +2. Here. And this is the vertexes where we u at, so it u down, like that. It'd make the parabola upside down. If I were to graph the whole thing, you can see what it looks like. So this is what it looks like. On this scale, I'm going by ones. You see this is 1, 1, each tick mark's worth 1. I could zoom out a little, and now this one's going by 2s, but then you would have to know, for example, that -3 is right in the middle of -2 and -4 and stuff like that. But that's what this graph would look like once you graphed it from factored form. So using the language in the CLO, what did you learn how to do in this lesson?